This is test review 4.5, numbers 7 and 8. So I'm going to factor the numerator and denominator. I will get x minus 3 times x minus 2 over x plus 3 times x minus 1. For my x-intercepts, I plug in x minus 3, not plug in, but set equal to 0, and I get x equals 3. I also set x minus 2 equal to 0, and I get x equals 2. Those are my x-intercepts. My y-intercept, I plug in the value of 0 for my x's, and that creates zeros for all the x terms. I get 0 minus 0 plus 6 over 0 plus 0 minus 3. Positive 6 over negative 3 is y equals negative 2. So I'm going to plot these points. X equals 3, x equals 2, y equals negative 2. For my vertical asymptote, I set the denominator equal to 0, both factors, so x plus 3 equals 0. I get x equals negative 3. For x minus 1 equals 0, I get x equals 1. So those are my vertical asymptotes. For my horizontal asymptote, I am looking at the n value over the m. Since these are equal, I look at the coefficients 1 over 1. I get y equals 1 over 1, which is y equals 1. Now I go to graph. I go to negative 3 for my vertical, one of my vertical asymptotes, and positive 1 for the other one. And my horizontal asymptote is at y equals 1. And now I am ready to test the behavior of the graph. I will test to the left and right of each vertical asymptote by point 1. Move that over a little bit. There we go. So if I go 1.1 units away from the vertical asymptote at negative 3, that's going to be negative 3.1 and negative 2.9. If I go 0.1 units away from 1, I will get 0.9 and 1.1. And I'm going to do my testing down below here. So if I plug in negative 3.1, I get negative 3.1 minus 3. That is a negative number. Negative 3.1 minus 2 is a negative number. Negative 3.1 plus 3 is a negative number. And negative 3.1 minus 1 is a negative number, which ends up as a positive value. When I plug in negative 2.9 minus 3, I get negative. Negative 2.9 minus 2 is a negative. Negative 2.9 plus 3 is a positive. Negative 2.9 minus 1 is a negative. 3 negatives make a negative. When I plug in 0.9 and subtract 3, I get a negative. 0.9 minus 2 is negative. 0.9 plus 3 is positive. 0.9 minus 1 is a negative. 3 negatives give me a negative value. And 1.1 minus 3 is negative. 1.1 minus 2 is negative. 1.1 plus 3 is positive. And 1.1 minus 1 is positive. Two negatives make a positive. So now I go graph these. For negative 3.1, I'm up here at the positive values, going towards positive infinity. At negative 2.9, I'm going down to negative infinity. At 0.9, I'm also going down to negative infinity. And at 1.1, I'm going up towards positive infinity. Now I'm ready to graph, although over here on the left side, I don't have any points. So I'm going to plug in x equals negative 6. When I plug in negative 6, I'm going to go down here. And if I do negative 6 in parentheses squared, okay, make sure you put that in parentheses, minus 5 times negative 6 plus 6 over negative 6 squared plus 2 times negative 6 minus 3. That's 36 plus 36 is 72. 36 minus 12 is 24, minus 3 is 21. And 72 over 21 is going to be around 3.5. So approximately 3.5. So at negative 6, I will go up to 3.5. 1, 2, 3.5, and plot that point. Now I have a point to go through, and it's telling me to stay up above the horizontal asymptote. In the middle here, both my arrows are pointing down. The other thing I need to realize, I do have a point, but I do not have any x-intercepts. So when I come up, I'm going to come back down, and I need to make sure I stay below the x-axis. So I'm going to go up through that 2, and then I'm going to come down through to negative infinity. Now, the curves in this graph are just because of the drawing from the template, the temp tablet, sorry, and trying to draw on here instead of just being able to draw directly. So just a nice smooth curve is fine. Over here on the right, you look at my points and they're down below the horizontal asymptote, but I'm coming from positive infinity. So what that means is I have to go down through this first point, come back up through the second point, and then level out across the horizontal asymptote. So I'm going to come down, I'm going to go through the 2, come back up through, and then I have to level out. Okay, and that's what my graph is going to look like. Let's go on to number 8. I'm going to erase this work. To give myself some room. Okay, so let's look at number 8. I need to factor. Well, I don't do anything with the top. And then for the denominator, I will get x plus 2 and x minus 1. For my x-intercept, the numerator is 1. And 1, if I try to set that equal to 0, it doesn't work. I do not have any x-intercepts. For my y-intercepts, or intercept, I plug in 0. So I'll get 1 over 0 plus 0 minus 2. So I will get 1 equal, or y equals 1 over negative 2, which is negative 1/2, which is right here. For my vertical asymptote, I set the denominator value factors equal to 0, so x plus 2 equals 0. I get x equals negative 2. And for x minus 1 equals 0, I get x equals 1. For my horizontal asymptote, I take the degree of the numerator, which is 0. Whenever there are no variables, I have a degree of 0. So n is 0, m is 2, n is less than m, which means my horizontal asymptote is y equals 0. So let's go ahead and graph these. I graphed my y-intercept. I don't have any x-intercepts. My horizontal asymptote is on the x-axis. When you're drawing that, what you need to do is make your dashed lines large enough for me to see over that axis. My vertical asymptotes are x equals negative 2. Okay. Sorry, didn't mean to do that. So x equals negative 2 and x equals 1. All right, and now I'm going to do my test points. Oh, I need that. Okay, right there. 0.1 units away from negative 2 will be negative 2.1. Negative 2.1. Yeah, I'll just rewrite that. Negative 2.1 and negative 1.9. 0.1 units away from 1 are 0.9 and 1.1. Negative 2.1, let's see, obviously the top is always going to be positive on all these because it's just the value of 1. So positive for the numerator on all of these. Okay, now I just need to worry about the denominator. So negative 2.1 plus 2 is a negative. Negative 2.1 minus 1 is negative. Two negatives make a positive. Negative 1.9 plus 2 is a positive. Negative 1.9 minus 1 is a negative. I get one negative value, which results in a negative. For 0.9 plus 2, that's positive. 0.9 minus 1 is positive. I have all positives, so my outcome is positive. 1.1 plus 2 is positive. 1.1 minus 1 is positive, so that's positive. And I realized I made a mistake over here. Sorry about that. Because 0.9 minus 1 is a negative number here. That gives me a negative value right there. All right, so negative 2.1, I'm going towards positive infinity. At negative 1.9, I'm going to negative infinity. At 0.9, I'm going to negative infinity. And at 1.1, I'm going to positive infinity. I only have one point here, and that's in the middle. So that means I'm going to test a value to the left and to the right over here. Okay, so if I plug in negative 6, that's going to be 1 over negative 6 squared plus negative 6 minus 2. That's 1 over 36 minus 6 minus 2, which is 28. That's a very, very small positive number. That's like right here, right above that asymptote. Okay? If I plug in positive 6, I will get 1 over 6 squared plus 6 minus 2. That's 36. Plus 6 is 42. Minus 2 is 40. That is 1 over 40. Again, a very, very tiny positive number. What I need to understand is that is on top of the x-axis horizontal asymptote, which means I will go down and stay above the asymptote. The other thing is I have no x-intercept, so I know I'm not going to cross through the asymptote. Okay? So I go down, and because that's so low, I'm going to have to be very careful and draw that. In the middle here, I have to go through that point and come back down. So I go up through that point and then back down to the negative infinity. On the right here, go from the arrow, and it's going to curve over and go to the right. Now, when you end up with those values extremely close here, and even if I plug in negative 1, I'm going to get 1 squared minus 1 minus 2. No, sorry, not negative 1. Negative 3. Squared is 9. Minus 3 and minus 2 is 5. So that's 1/5. So it's still a fraction. So really, I come down and I get really close, and it's a very sharp curve down here when you're doing that, as far as understanding this graph a little bit. Okay? And that's number 7 and 8.